All right, all right. Hello, hello. Happy Friday, everybody. Welcome back to Tech Stack Nation. We are very excited to have the Angular team back with us today. I want to give a quick shout out to our beloved sponsors, AG Grid, who are doing amazing work as always. And I want to introduce Dylan and Miles from the Angular team. How are you? Dylan, we've had you here before. It's been too long. How are you?
I'm doing really well. Yeah, it's been maybe like 2 years since I was last here to talk about typed forms.
I know. We need to have you here more often.
Yeah, I'll reach out more in the future, I guess. But today we're going to talk about the Angular compiler. So I guess let me present my deck here.
Wait. We need to meet your special guest first.
Yes, so let me introduce myself. My name is Dylan Hunn. I'm a software engineer on the Angular team. And my co-presenter is Miles Malerba, who is a software engineer on the Angular team as well, working both on the framework and on components. I don't know if you want to introduce yourself, Miles.
Yeah,
Welcome,
sure.
Miles.
Hello, everybody. Yeah, so I've been on the Angular team for a while. Primarily, I work on the CDK and material design components. And this project was actually kind of my first venturing into working with the compiler. So it was a fun learning experience for me.
Yeah,
Nice.
in the past, I've mostly worked on the compiler and on forms and on the language service, so kind of all over the framework repo.
We do a lot. We talk a lot about forms. We talk a lot about the CDK and material here. So I'm sure we'll have lots of questions later, but we're really excited to get into this and learn about the new template pipeline.
Yeah. So we have maybe like a 20 or 30-minute deck here, and then we'll do some Q&A at the end. So we want to tell you about this big project that we did called the template pipeline. So first, I'm going to give you some background on why Angular compiles templates as opposed to just interpreting them at runtime. Then I'm going to motivate why did we build template pipeline specifically, what does it do, why is it useful. Then we'll dig into some of the design details of how this thing works. We'll have a look at some of the details of compilation, although there's too much to cover in one presentation. And then at the end, we'll look at some takeaways that we learned from doing this project. So first, let's start with why the heck do we compile templates at all? So when you write an Angular template, it gets ahead of time compiled or really transpiled to something we call an IV view function. So IV was the code name at the time for a big rewrite of both the compiler and the framework runtime. And IV has this notion of a view function. And a view function is responsible for creating and updating the DOM for a specific fragment of a template. And we call these fragments of templates views, and they are more granular than entire templates. So say imagine that you have a component, and inside that component you have an ng template, or maybe you have an ng if, anything that implicitly creates a nested ng template. That would be a view. So that's sort of an isolated fragment of the template that we produce a transpiled view function to create an update. So you could write one very large component with a ton of ngifs, and it can result in dozens or even hundreds of IV view functions. And each one of these is basically atomic. They don't depend on other view functions. They can refer to other view functions by selector, but they don't actually have to import them. So sort of the net result here is that each of these little pieces of your template, each of these view fragments, can be atomically compiled into an IV view function. This is sort of the basic unit of rendering and updating the application. And inside each IV view function, we have a bunch of things that we call instructions. And these instructions are not machine instructions. They're actually just JavaScript. But the runtime defines a pretty large set of these IV instructions that specify behaviors the runtime can perform. And we divide them into two categories. We have create mode instructions. I'm going to try drawing on my slides here. Yeah, create mode instructions. And these are responsible for creating elements in the DOM or configuring data the runtime will need to eventually update the application. And these only run once when the component bootstraps. And then we have update mode instructions. And these run every time the application changes to text. And all of the instructions begin with theta theta. We commonly use this theta prefix to refer to Angular internals, but in this context, theta theta is always going to mean instruction. So the portion of template compilation we're looking at here is actually a fairly small portion of the overall compilation flow. So the user writes the Angular template, and it goes into the parser. And the parser actually has two phases. So the parser first parses HTML, and then we have a second parser that runs and parses Angular specific expressions. And this produces the abstract syntax tree, or AST. And this is specific to Angular Ivy. So it is a tree-like data structure that describes all of the nodes and all of the data stored in the template that you've written. And then we can simultaneously execute the two different parts of compilation. So the part that we're talking about today is the template compiler. So this actually produces the Ivy instructions that run in the browser to create and update the template. The other part, which we are not talking about today, is the template type checker. And the template type checker is what's responsible for producing template diagnostics. It's basically responsible for Angular's understanding of the semantics of the program. But the stuff that actually executes to render the application is the template pipeline that we're going to be talking about. So that's sort of a high-level overview of what template compilation looks like. So here is an example, and it's not as overwhelming as it looks, I promise. So on the left side, we have a fairly short template. So we have a div on the outside, and then we have two things inside. We have an interpolation with a message inside of it, and then we have an @4. This is the new @4 block syntax, which I really wanted to include because I think it's great. And so, as I mentioned a second ago, views are more granular than templates. And so this template actually has two views in it. There's this outer view, and then an inner view corresponds to the ng template implicitly created by this @4. So here's the outer view here. And as you can see, we talk about it being an Ivy instructions, but really it's just a JavaScript function. So we have the main app template here, and it has two modes. It has a create mode and an update mode. And the create mode has 4 create instructions. We have an element start to create the outer div, a theta text that produces the slot in which we're later going to interpolate the text corresponding to message, a repeater create. So this is a special new instruction that creates the slot for this @4 to occupy, and then an element end, which ends this enclosing div. So that's actually all the instructions this outer view needs to configure the DOM. And inside of these instructions, the runtime implements these instructions and will actually do the document.create element that's required to create this div. So then in update mode, this runs every time the application changes to text. And we have a bunch of instructions here. We'll get into more detail about what most of them do, but some of them are pretty self-explanatory. Like text interpolate grabs this slot created by the theta text in the create mode and interpolates the string message inside of it. So then we also have this nested view function. And again, because @4 implicitly creates an ng template, it gets split out into its own atomic view function. So we have multiple view functions for this template. And the inside of this 4 is actually really simple. We just have a single interpolation. So we have the theta text instruction that creates the slot for that text interpolation. And then we have a text interpolate instruction here. And this grabs the current value of item.name and inserts it into that text interpolation slot. So this should sort of give you a flavor for what the compiled output of an input template looks like. So we can do a lot of stuff that we could not easily do at runtime because we compile these templates. So here are some examples. We can allocate the right amount of space we need to render the template. I'm going to show you in a second, there are some cases that require temporary intermediate variables, and we can count how many we need at the beginning and allocate them. So I showed you a second ago, we allocated a slot for that text binding. We can count how many slots we need and allocate the right number of them. So basically, these features let us use the JavaScript heap a little bit more efficiently. And then we can do a whole other class of things that would be impossible without static analysis. So when you defer on viewport for a specific element, you're referring to that element by its selector. And we can do that at compilation time. We can sort of walk the application and look for that selector. And that's much cheaper than having to do it at runtime, where the selector could be like higher up in the application and we'd have to walk all over the place trying to find it. We can also do stuff that you typically associate with a bundler, like extract constants. And we can often do it better than bundlers can do it because we have Angular-specific knowledge of what kinds of optimizations are valid. So these are some reasons that justify the decision to compile the template in advance. So here's an example of the temporary variables case I just discussed. So on the left, we have the input template, and we have a nullish coalescing inside of it. So if first name is null, then we choose the string Frodo inside this interpolation. And For those of you who know your Angular trivia, nullish coalescing in Angular actually predates nullish coalescing in JavaScript. And so the semantics are a little bit different. In JavaScript, if the left-hand side is falsy at all, you get the right-hand side as the result of the expression. Not so in Angular. In Angular, the left-hand side needs to be specifically null or undefined. So we cannot omit the JavaScript nullish coalescing expression because it has different semantics. So what do we do instead? We generate this expression. So this is a ternary expression that checks to see if context.firstName is not null and is not undefined. And if it's not null and not undefined, then we return first name, otherwise we return Frodo. And you'll notice that we have to evaluate first name here 3 times. So if we didn't have this temporary variable assignment, we'd say first name here, first name here, first name here. And so if this is like a getter, for example, and it has side effects, this is invalid, or at the very least, it's surprising, right? That your getter would be run 3 times and the side effects would be observed 3 times. So we really don't want to do that. So instead, we take advantage of the fact that we can ahead of time compile, and we do this temporary variable assignment, where we store the result of first name in the temp the first time that we read it, and then we use that temp the next 2 times. So now side effects from calling .firstName, say it's a getter or a setter, only happen once. And also, we know how many temporaries we need, so we can initialize or allocate them at the beginning of the update block. And so if we needed 25 temporaries, we allocate them all at once, and that performs a lot better than allocating them as we go. So that's just sort of a quick in-practice example of the kind of thing we might ahead of time compile. So why did we do template pipeline as a project? Because we already had an old compiler, and that compiler was called Template Definition Builder, and we decided basically to rewrite it with this project. So why did we do that? The biggest issue was that Template Definition Builder was extremely monolithic. It was sort of structured as one visitor that visited all the nodes in the abstract syntax tree and transformed them. And this really mixed together a bunch of different topics. For example, we have a bunch of features related to internationalization that require ahead of time compilation, and all that code was mixed up with the code to like allocate and count temporaries. That made it very hard to maintain and hard to add new features. The other issue, sort of the other big top level issue, was that Template Definition Builder eagerly reified into JavaScript. And what I mean by this is when you see those like theta text interpolate, Template Definition Builder would just emit a JavaScript expression immediately that was theta text interpolate. And this was a problem because sometimes you might want to go back and apply additional modifications or transformations, and you'd have to go grab that already reified JavaScript instruction in the syntax tree and like get in there and modify its arguments. And this turned out to be really messy. Some other consequences were that it was like this one big monolithic class, and it was kind of hard to follow. And we have a bunch of new features that were coming up at the time this project was proposed. Some of them were signal-based components, zoneless, signals-based forms, partial hydration, and the big one here is selectorless, where we are talking about allowing you to refer to components by their class name instead of by their selector. And this isn't designed yet, but it's going to be an enormous change to the compiler. And we felt like Template Definition Builder had been kind of stretched to its breaking point. So wouldn't it be nice if the compiler was more modular? We could prototype a lot faster. We could make these big changes that we're thinking about making. And so was born the Template Pipeline project. Our main principles for designing it were that we wanted it to be totally modular, so we could turn on or off individual parts of the compilation. We wanted it to be extensible, so that we could easily add new aspects of compilation without breaking the old one. And we wanted it to be maintainable, so we isolated the different concerns, like I18N from temporary variables. Those should be in totally different places in the code. And the decision we made about how to design this was to use a classic compiler's idea called an intermediate representation. So an intermediate representation is, instead of immediately reifying the input AST into output JavaScript instructions, we have sort of an abstracted intermediate set of instructions that we use before we emit the final instructions. And we can specifically choose these to expose the data fields that we care about modifying in future phases or future passes. And we don't have to like get into the reified JavaScript instruction and mutate the arguments and stuff like that. So we're no longer immediately finalizing into JavaScript. We instead have this intermediate representation, and we structure the compiler as a series of phases, each of which does a small incremental transformation on the set of IR that describes the template. So here's an example of an aspect of compilation that really benefits from having an IR. And this is bindings. So it turns out Angular actually has a ton of instructions for bindings under the hood. When you actually do like a square brackets binding, a lot of them feel the same. But if you do like a square brackets binding to class.foo, that actually results in a totally different Ivy instruction than if you do a square bracket binding to just a plain old property. And the reason for this is that the parser figures out, you said class.foo or style.color. And then we compile these Ivy instructions and the runtime doesn't have to reparse it. The runtime can just say, this is a class instruction. I already know I'm updating a class on this element. And we don't have to have all that parsing logic in the runtime. So we have a bunch of different kinds. We have the basic property binding. Attributes bind to like DOM attributes. This is like attr.foo. Style is for like style.color. Class is for like class.hasBorder or something. And then host bindings bind to a property on the host element in the DOM. So these are all the different binding kinds. And here's an example of how we compile them. So a plain square bracket binding is a property binding. This is an attribute, this is a class, this is a style. So we have a bunch of different binding kinds. They all correspond to different instructions. I've kind of got them out of order here, actually. Like this is the property. Sorry about that. This is the attribute. This is the class. This is the style. So yeah, different instructions for different binding kinds. So what we decided to do was add an IR op, or an intermediate representation op, that corresponds to all the bindings. So we have this one binding op, and any binding that you specify in your template gets ingested into this binding op. And then all the logic that's common to the various kinds of bindings can be factored out into phases. So some of the bindings require extra parsing, like for style bindings or for style maps, you might need like 3px, and that has to get parsed into a number and a unit. A lot of bindings contain sub-expressions, like you can put a pipe inside of a binding. And now, instead of having to look for pipes and simplify those expressions inside of 5 different binding kinds, we can do it just in the binding IR op. It's the same with interpolations, where you could have an interpolation string inside of your binding and have multiple interpolations in there. And now we only have to apply that interpolation logic to the binding op. Internationalization is another one of these cases where you can do I18N-foo and then internationalize your foo binding. And we can centralize all this logic in one place. And then only at the end, after we've applied all these transformations that are common to the bindings, do we specialize into property, attribute, class, style, host, whichever instruction it might eventually become. And so by adding an IR op here, we were able to factor out all of this common logic that applies to the various binding kinds. Another example of a topic that benefits from an IR is slot assignment. So every creation mode element implicitly occupies a slot. And you can think of a slot as just a counter. So if you have a div, then a span, then an input, the div might be at slot 1, the span at slot 2, the input at slot 3. And then when we're in update mode, we have these instructions like text interpolate that say, grab some text, interpolate it into the text slot. And the way the runtime knows which create mode instruction, aka which element in the DOM we're talking about, is based on the slot counter. So let me show you an example of this. So here we have 3 components. These could just as easily be divs, because remember, these view functions are atomic, and so we don't actually really care about what's inside here. We just create an element with the selector comp A. And we create 3 of these elements, comp A, comp B, comp C. And these implicitly get slots 1, 2, and 3. I think actually, sorry, 0, 1, and 2. And then we have these 3 property bindings in the update block. This is the update mode here. We bind .A, .B, and .C, and these are at 3 different slots. So we advance the slot counter in between each of these property update instructions. And this is way easier to do with an IR because we can link these together. Do I still have my... No, I took away the animation. We can link these together using cross-references. So we'll assign just an integer or just a number to this creation mode element, and then we'll assign the same cross-reference number to this property element. And these will get linked together explicitly. Same with these, and same with these. And then we can have a phase that goes through and inserts these advances. It says, Whenever the cross-reference number of the update instruction changes, I know it's time to insert an advance. And so we previously had this very complicated logic about how do we know when to advance in the update block. And now we have a phase that goes through and inserts all of the advances. So this is another example of a win we got from adding cross-references that point to slots. So I actually pretty much just explained this slide. Here is the animation I was looking for, where we've got our create mode elements linked to our update mode elements by a cross-reference, and then we can go through later and in the update mode, look for when those cross-references change and insert the advances. Okay, so I'll turn it over to you, Miles, to talk about the details of compilation.
Yeah, sure, thanks. Yeah, so as you heard Dylan talking about, we have this pipeline now that's made up of these different ops. So the intermediate representation is basically like a linked list of these op things. And then we have a whole bunch of different phases that like kind of rearrange or modify these ops in some way. And so it's structured as we have this initial ingest step that is technically not a phase, but you can think of it as a phase. It's the very first phase that takes, you know, for the parsed AST and converts it into this IR representation that we're going to be using. And then we have, you know, at the time that I originally wrote the slide, around like 60 phases. I think there have probably been more phases even added at this point, that each do like, you know, little incremental steps to get us a little bit closer to the final state that we want. And then somewhere towards the very end of that pipeline, we have this reify phase that is the one that kind of actually takes the IR and converts it back into our actual output. And so what do we do while we're transforming the IR along the way during these phases? There's a couple different things. So we might be like adding in completely new ops. We might take out some ops and replace them with others, just delete ones that turn out to be irrelevant, or like update some of the expressions and things that they reference. And in addition to that, there's kind of like some, you know, metadata about the whole thing. Like we have an array of constants and like variable counts and things like that. So we might kind of go over our ops and update some of these sort of things. And so to get a better idea of like what one of these phases might actually be doing, I figured we could go over a example of one of the phases called propagate I18N blocks. And so in order to illustrate what that's doing, just got a small example here where we have an unordered list. We've marked it for I18N, right? So we want this to be internationalized. And then inside of it, we've got NG4 to create our list elements. And then some of the elements, you know, represent something new. So we'll put a little like special flag on them using our ngIf to add some like super text to them. And so let's take a look at what the create IR would kind of look like for this. So again, it's like this linked list of ops. And this is only capturing the create part, not the update part, as Dylan explained. There's kind of
and each one of these boxes is one of the IR ops.
Yeah, each one of these represents an IR op. And so as you can see for the root view, like the UL here, we've got kind of like this op saying that we're starting our elements, I18N start op, which indicates that we're starting a block of internationalized content. And then inside of that, a template op, because all of this star NG4 stuff, right, as Dylan explained earlier, that kind of goes in its own view. And so the template op links us over to that other view. And then, you know, after the template, that's kind of the end of our I18N block, and then the end of our element. And so pretty straightforward template there. And then inside the NG4, we've got the element start, but then no I18N start, right? So like we've kind of lost the fact that we're inside of an I18N context here and that this actually needs to be internationalized. And so that's what this phase is going to help us do, is actually like propagate this I18N block down into the child templates. But yeah, so then inside the element.start, it's got this text, another template for the ngIf, and then the end element. And then the ngIf one is super simple, just start of element, some text, and then end of element. So yeah, what we want to do in this propagate ITN blocks phase is to kind of push these ITN ops down through these child templates. And I don't know if my animations are going to work here. We'll see. We'll see if. Oh, okay, it is. So what the phase will do is we're going to start off by going through the IR on the root view here. And when we hit this ITN start op, we're just going to kind of note to ourselves, hey, it looks like we're now inside of an ITN block. We should watch out for any templates that we might need to propagate this down to. And then at this point, the very next op, we find a template. And so now we know, indeed, we're in an ITN block, and we do need to push it down into this template. So we'll jump over to the IR for that view, and we'll insert at the very beginning an ITN start op, and at the very end an ITN end op. And so now this child template is aware that it needs to be internationalized. And these ITN ops contain kind of the information to link it back up to the same message as the root one, so it can all be put together as one like translated message, right? But now we're not quite done yet, because there's still further templates inside of here that need to be added to this message as well. And so now we'll just kind of start doing the same thing through this view that we just propagated to. And very first thing, because we just added, obviously, we're going to hit this ITN start op. And now we know, again, we're in an internationalization context. And a few more ops down, we find this template op. And so we know that we have to propagate to that. We do a similar thing. We insert the ITN start and ITN end. And then, I guess I don't have any animations for it, but we do run through this last one as well. And we see, okay, there's no template ops. I guess we've kind of hit the end here. And so that's just one tiny piece. As I said, there's like 60 plus of these phases. And this one just kind of handles like this little small piece of internationalization. Yeah. And then Dylan, I think you wanted to talk about the variable optimizer maybe?
Yeah. So I thought this one was really cool. So you typically associate optimizing variables in your app with something your bundler does. But Angular can actually do a better job because the Angular compiler has a lot of Angular specific knowledge about the variables that we generate and when they can be inlined and when they can't be inlined. Why do we do this? So sometimes we need a reference to a different context or view. So you could be reading, like, say that you're inside of your template and you're reading a property of the enclosing class. We need to get the context variable corresponding to that class. And template definition builder used to lazily omit these. So it would look for places where you're like reading a field on your component class and omit the context variable required to get access to that field. We do something totally different in template pipeline where we eagerly omit every possible context you might need. So for all of the enclosing components of the tree, and then we have an optimizer that goes and finds the ones that you don't need and eliminates them. Or as I mentioned a second ago, we can figure out sometimes that we can inline them, like if you're only using them in one place. And we can be very aggressive about when we inline them because we semantically understand what other instructions it's safe to move them across. Whereas something like a bundler wouldn't be able to understand that. It would see any function call and be unable to inline it. So here's an example of some context reads. So we have a simple component here on the left with a click handler. And we call the foo method. And this is a method on our component class. And so we actually generate so context is the context variable corresponding to this view function. So this is the context of the class instance, and we call context.foo here. So this foo method is on the component class. Then we also have this onClick, and this is another method on the enclosing component class. So we call context.onClick here. Yeah, this is just kind of like a quick example of how we generate context variables and why you might want to read them. Oh, I forget why I added this slide. Sorry about that. I can pass it back to Miles for takeaways.
Yeah, so yeah, so we had a couple, kind of important like learnings and takeaways from this. The first like most important thing I think that we took away is that like if you want to do something like this, like having thorough tests is really important. The logic in the template definition builder, was doing a lot of things and was very hard to decipher sometimes. And so you kind of needed to have these thorough tests to give you like any confidence that you were maintaining the same sort of behavior with the pipeline. And so luckily we actually did have this. There had been a lot of like tests added for the template definition builder over time. And so that allowed us to kind of slowly build up the pipeline by ignoring the 99% of failing tests and just focusing on getting that 1% passing, and then incrementally improving and refining our implementation until it got like closer and closer to the template definition builder. And then we also kind of had the advantage of the fact that Google has like one of the, if not the biggest mono repos in the world. And so we were able to, bring this in and then just kind of run it against these hundreds of Angular apps and see if any of their tests failed. So that was a good way to catch anything that our tests might have missed. Although it's certainly easier to debug, when you have a focused test case instead of just like, oh, you broke, some random giant app somewhere, and now you have to go dig in and figure out what exactly happened. So still very important to maintain your own tests. And then another thing we kind of took away is that it's okay to sprinkle a few bugs into your implementation once in a while. So we kind of had an opportunity here to just kind of start from scratch with some of this crazy logic, and in some cases wound up with behavior that was more correct in the template pipeline. But more correct isn't always a good thing when people have come to rely on your crazy bugs that you've accumulated in template definition builder. And so there were some cases where we actually kind of went out of our way to re-implement existing bugs. Of course, we tried to do this in a way where we're documenting like, hey, why am I intentionally implementing a bug here, and guard that with a flag so that later we'll be able to like turn it on and off, see how many failures it causes, and address some of the apps that might have been relying on the buggy behavior. But in the short term, if your goal is to actually ever land your change and get the new compiler in, it's easier to just kind of reproduce some of this buggy behavior. I think I have an example here of one of my favorite like buggy behaviors that I ran across. And so I have a component here that just matches on tab index as a like attribute selector. And then another component just to test like what elements is this going to match on. And so using tab index in a couple different ways here, and we'll see which one that first component matches on. And we can see like probably, you would expect it matches on the first two. The third one, it doesn't, and I'd say that feels correct to me, like you're trying to set an attribute here, not match a directive. And the really weird part is that if you do class.tabIndex, the directive matches on that. So you don't have that property or attribute or anything here. You're actually just setting a class. In fact, you're not even setting a class because it's not equals anything. It's just kind of an empty binding. And the directive will match on that, and that creates a directive. Same thing for style.tabIndex, which is again completely insane. And then if you actually do assign your class.tabIndex equals true, suddenly the directive doesn't match. So go figure. It's a very, very strange buggy behavior that we encountered, but interesting, I thought, to bring up. And then, yeah, another thing is that, because the template pipeline was architected very differently from the original template definition builder, which was kind of this like single traversal, it was often difficult to get the exact same output. For example, like the ordering of certain things, when you're doing it in a traversal versus like many passes. I think we had this issue with like our constants array, right? So it used to be kind of a mismatch of like constants that came from different extracted bindings versus like I-N stuff, and it was all like mixed together based on the way that the traversal was happening. And now we've separated that logic out to be a lot more sane, and it's does maybe like the bindings first and later does the I-N, but that causes the order in the constants array to now be different. And this functionally like is not a big deal, but it is a difference that shows up if you're doing any kind of golden tests. And so you have to make sure that your golden tests are flexible enough to handle this kind of thing. And if it is easy to like keep the ordering the same, I would advocate for doing that, because it's say that there's one of these test cases I was talking about earlier where we were not able to catch it with our own tests. We like brought it into Google, ran this app, and now we're investigating what are the differences between the output before versus the output now. If you have all this noise in here from just like things reordering, that makes it a little harder to investigate. So if it's possible, it's good to eliminate as much of this like difference as possible and keep it looking relatively the same, but it's not practical that you're going to get 100% the same. And so having tests that are flexible is good in those cases. And another thing that we realized is that the template pipeline reduced a lot of complexity for us. It was great. One thing that it did introduce is this new kind of caveat that the ordering of the phases can be kind of tricky to get right. They make assumptions that other phases will have run first and done things to the IR. And so if you reorder it in a way that it's not really expected to work, that can introduce some subtle bugs. And in fact, there was one point where I was working on the I-N phases. There's like, I don't know, like a dozen or so phases that just have to deal with I-N. And I actually got into the state where like my phases had weird dependencies on each other where it was impossible to get them to work in any order. And so I had to refactor the way that worked a little bit, so that I could actually have a valid ordering for my phases where they all ran as expected. Yeah, I think that is all we had.
Yeah, so I hope that was an intelligible overview of the project. It really depends on a lot of Angular internals, but we tried to like motivate why did we do this thing. So thanks for having us, Bonnie, and I guess we ran a little long, but we still have some time for Q&A.
No, it's okay. It's okay. I told you we're super chill here, so there's not like an exact deadline or anything. That was really interesting because we don't see necessarily like what goes on, behind the curtain. So it's cool to see a look inside the Angular internals. Very cool. Okay, does anybody have questions? Raise your hands. Craig.
Oh yeah, thanks guys for that. That was interesting. And like Bonnie tried to explain before, we're usually implementing Angular apps, so we're not really down in the nuts and bolts except for rare occasion. But I am interested in the compile pipeline from when you start building to the end. Is this template pipeline kind of in there in some phase after the TypeScript compilation, the TS config stuff, the TS compiler runs? And are there other parts of Google that handle different parts of the compiler that all have to sort of make sure that they're working together in order?
Yeah, so let me actually present this again, because I have a slide that is maybe relevant. Okay, here we go. Yeah, so I showed this like super simplified slide, right? Where you have the input template, and then we parse it, and then we have these two component pieces of compilation. The template pipeline is the compiler on the top, and the template type checker is on the bottom. Mm-hmm. So when we think of the TypeScript part of the build, we're mostly talking about the type checker.
I see.
So this is actually by far the most expensive part of compilation. And basically the way it works is it's this whole separate compiler where we take your template and we generate TypeScript corresponding to the template. So everywhere you create an element, we generate like a little TypeScript statement that corresponds to creating that element. And then when you bind properties to it, we like call methods, like fake methods on that element. And this code never actually executes. It just exists in order to generate compilation errors. And so that is how we know when you're like binding to a property on div that doesn't exist, for example, or when you're trying to bind to an input on a component that doesn't exist. Is we call these things under the hood type check blocks, but really it's just we generate these TypeScript programs that describe the semantics of your template. So we have kind of these two parts of compilation. The template pipeline, which we just described, generates the code that actually executes to render the app. And the type checker generates the code that checks the types of your application. And the template pipeline doesn't really need TypeScript per se. I mean, we're like super tied up with TypeScript as part of our build process, but it's like it's not obvious from reasoning from first principles that TypeScript should be a key part of that. Whereas the type checker like totally depends on TypeScript. And so as a result of the fact that we really need TypeScript for the template type checking, we have structured the whole compiler as kind of a wrapper around the TypeScript compiler. So you configure Angular options in your TS config, and then we are able to like run the TypeScript compiler for subprograms. So like when you have little TypeScript expressions, or you need to compile the TypeScript class that's attached to each template. Like in your component, you have the template, and you also have the TypeScript class. And we generate the type check block from the TypeScript class. Then we have to compile the class. So like there's a lot of TypeScript stuff going on. And so that's why it's structured that way. But the part that we talked about today is just one very small piece of the overall compilation, which just generates the instructions that render the app. Yeah. So did that answer your original question? Kind of got off on a tangent.
Yeah. That was helpful. Thank you.
Okay, raise your hand if you have more questions. I have a question just out of curiosity. Miles, because you were on the CDK, you're working on the material team. How did you get dragged into this?
I actually just kind of volunteered to get dragged into it. Like I said, I've been on the CDK and component stuff for a long time. I don't even know. I've lost count at this point. Maybe like 6 or 7 years. But I felt like it would help me to have a better understanding of like some of the more nitty gritty stuff of how it actually all works.
How'd that go?
It was. I definitely have a better idea how it works now, and yeah, I think it was a valuable exercise. I do think it has helped my components work in terms of like really understanding better. Yeah, some of what's going on behind the scenes. This, and also I'm helping on some of like the zoneless effort right now, and so I think that's kind of helpful with my understanding of change detection. And so both of these things, I would say, have been valuable to my work on components, of actually knowing what I'm doing a little bit better.
Yeah, it's pretty crazy because I worked, I was enterprise consulting and working a lot with developers who are out in the world writing using Angular. And so you can actually do quite a lot without ever really learning about the compiler or change detection or Zone.js, because it's just there under the hood doing its thing. So it's really interesting.
Absolutely. I feel like people just kind of have mental models at like different layers of abstraction, right? And so like, it's not that I was like wrong or anything. It's just like my mental model stopped at a certain layer of abstraction, and being able to go like, a little bit deeper in some cases is valuable, I think.
Yeah, at some point it's just magic beyond that.
Yeah.
This stuff absolutely leaks out though. Like if you've ever been debugging an Angular application and you accidentally didn't have source maps for some reason, you'll definitely recall that you see these theta instructions. And so now you know what they are.
Yeah, that's pretty cool.
But yeah, Miles, sorry, yeah.
No, go ahead.
I was going to say Miles is also working on the zoneless effort now, which I have not been involved in. It's a whole other can of worms, much more on the runtime side.
Yeah, and especially the I18N also, like that's I've seen so many developers out in the wild like working on that, and it's so great to see Angular, because that's such a common use case. Like so many people need I18N, and it's become really important. So it's nice to see it like fragmented down into the IR ops. Eris?
Hi.
Hello.
In which Angular version is the new Angular template pipeline available?
I think it's 17.3. Shipped
Sorry, I
in
didn't quite catch
17.3.
the question.
Which version was the new template pipeline available?
Yes, it is enabled by default in 17.3, and it is the only compiler available in 18. It's coming up in a couple months, couple weeks. Yeah, I think a couple weeks. Wow, time flies. It actually was available as early as 17.2 if you set a secret tsconfig option. But it is default in 17.3, and it landed fairly seamlessly. We got a couple bug reports, but only 2 or 3, which is positive affirmation that our approach of running Google 3 was successful for testing. All the bugs that we got pertain to app4 and at defer, because people haven't really adopted them yet inside of Google. And so running our global pre-submit test didn't catch the issues.
All right. Good question, Ari. Pavel. The birthday boy.
I want to make sure that I understand correctly. In terms of generating these views, we can say, always the first step is like creation mode. So first of all, the element is going to be created, and then after creation mode, it's going to work. It's going to switch to the update mode.
Yeah, exactly.
And okay. And it's running one after another, or it's running like it's firstly creating all the elements and then it's creating the updating modes.
Yeah, so the creation mode, this RF stands for render flags. It's like it's a little bit of hieroglyphics for kind of no reason. I probably should have added a comment here. So this is the create block, and this is the update block. So the runtime runs the create block once. So this code here runs exactly once, and we run these 3 element instructions to create the 3 elements in the DOM. And once this is run, it never runs again. Then every time the application change detects, including immediately as part of the first change detection, we run the update block. And so this runs over and over again with every change detection. And so this block, the example I showed earlier, is binding values into properties named prop on these 3 elements. But basically anything in the application that needs to be updated dynamically will have instructions in the update block.
Yeah. Okay. Thanks.
Good question. Awesome. Anybody else have more questions? All right.
Yes. When you create a slot, if you have, let's say, 4 or 5 instructions and you create the slot, the order of the slots is does matter, or the framework doesn't need to know. It just creates slots.
All right. I don't know if you know, but your audio is very strange.
Okay.
It's kind of hard to understand you.
Yeah, but it sounded like you were asking about whether the order of the creation elements matters. Is that the
slots? The order of the slots.
Slots.
On
The
the
slots?
on the
slots?
SSR?
Can you say it again, Ari?
If the order of the slots matters.
Yes, the order of the slots very much matters. So again, with this same example, wait for the presentation. So each of these elements implicitly occupies a slot. And the reason for that, I say implicitly, it's because we have a set of instructions that are known to occupy slots. An element is one of them. So each one of these elements occupies what sometimes we call it a data slot. And then you might wonder, how does each of these property instructions know which element instruction it applies to? And that's because they are linked together by slots. So this first property has the same slot as this element. And so we know this property applies to this element. Same with this property, it applies to this element. And then at update time, the runtime has a slot counter. So we say the slot counter starts at 0 here. And then here the slot is 0. And that corresponds to slot 0 here. Then we advance the slot counter. So now the slot is 1. And that corresponds to this slot 1, etc. So the slots, you could think of the slots as a way of synchronizing the create and the update instructions, where the create instructions occupy slots and advance tells the runtime which slot is currently active in order to synchronize the application of the update property instruction to the create element instruction. Does that make sense?
Yes. I was also thinking like why there is no advance function under it, and now it makes sense.
Yeah, we put it in between the update instructions so that this
Mhm.
the runtime's ambient counter is pointing to the correct instruction in create mode. It's like the synchronization mechanism to get these update instructions to apply to the right create mode slots. And here the slots they correspond to DOM elements, so it's fairly straightforward. But we can use a slot for anything that requires stored data to be updated. So we also use slots. Forget all the things we use slots for. I think we use slots for a bunch of internationalization things too, but I think the details are kind of unimportant.
That was a very helpful question, Ari. The slots make sense. Pavel, you had a hand up. Did you have a question, or was your question answered?
Oh, that was the same what Ari was basically asking. I just wanted to ask like if there is some wrapper around or something, because when I was reading the code, I also was like missing the identifier which of the instruction here is connected to the element, So basically, this was the answer for.
So kind of the big improvement that I was trying to describe earlier with template pipeline is that it used to be the case with the template definition builder that it would emit these update instructions one at a time. So it would emit it would emit the property instruction, followed by the advance instruction, followed by the property. And like goodness help you if you want to go back and add more update instructions, because all these advances have been eagerly inserted into the update mode block. And if you want to add another create mode instruction, like maybe an ITN instruction, for example, now you have all these advances you have to move around, and it's a disaster. And so as a result, this kind of forces you to handle all your concerns eagerly in one place and mix all your concerns together before the advances get emitted. Whereas what template pipeline does is we use these abstract cross-references, which are just counters, to link create and update mode ops together. And then at the end, we have a phase that goes through and inserts advances. And so that approach is way more flexible because we have the freedom to go back and say, actually, I want to change the list of create mode ops. I want to add additional update mode ops. I want to move them around. And we don't have to worry about relocating these advances that have already been generated because we link them together using this cross-reference abstraction, and then we emit the advances later. So that was sort of kind of the crux of the improvement that we got by moving this into a phase.
Okay, this is very cool. Okay, so my last follow-up question, I think, about if anybody else has questions about the template pipeline, let me know. So I think, do we all understand the IR ops? Because the IR ops for me was like it's intermediate representation. And I think this kind of goes back to, I don't know if you guys remember Alex explaining Ivy to us, how you basically just want to break things down because there's like Angular is bringing in so many different things, but when you're displaying it, you really want it to be as simple as possible. And so the intermediate, what is it? Intermediate representation, the IR op is just like a reusable block that we see over and over again.
And a lot of these IR ops actually correspond to ops we eventually emit. I'm using the word op interchangeably with instruction in that context, where, like Miles was showing element as an IR op. And eventually, when I showed you the compiled Ivy code, there's an element instruction in there that creates the div element. So in that case, the IR op is just a nice little TypeScript interface that eventually gets emitted as theta element JavaScript instruction. And so in most cases, actually, these IR ops just directly correspond to output instructions. But there are some cases where it's useful to have extra ops for keeping track of data. And I don't think we really got into any of those cases. Did we get into any of them, Miles?
I don't think we showed any, but like ITN context is a good one. Like just like I was mentioning that all those different like views had to kind of be connected together into one translated message. And so there's an op in there that I didn't show called ITN context that kind of like keeps that linkage until we're ready to output the translated message into the const array. And at that point, that op is no longer needed, and we just delete it. So it's just kind of this like transient op that's in there to simplify the logic.
Yeah, because we have, all these views, like Miles showed the example of 3 views nested inside of each other that all participate in the same internationalized block. So the ITN context lets us keep track of the message that will eventually be emitted, like the internationalized message string that describes all of the views nested together. But we never actually emit an instruction. So we can have like helper ops like that. But I think really the big win is that instead of just emitting JavaScript, we can mutate the data in those ops super easily. And so we can have phases that go through and modify the op data before we reify them into JavaScript. But yeah,
This is really cool.
Really kind of a nuts and bolts internal idea.
I love it. Okay, so as far as for all the Angular developers out in the wild who are keeping up with this, I know Miles mentioned that it's really good to keep your tests updated and keep your and make sure your tests are testing the right things and having them flexible so that you can catch things like this. And then also, I think keeping up with the latest versions is always a good idea. Is there anything else? Is there anything that we should know about like how to best structure our data so that we can take advantage of these changes? Or is this all like under the hood stuff that we don't even really need to do anything differently?
Yeah, so the stated goal of this project was to have nobody be aware of the fact that we swapped the compiler out from under them. And I think we have actually succeeded in that, which I was dubious of when we set out to start this project, because we did like this big monolithic, let's rewrite it, which in my opinion is not usually a good idea. So maybe that's kind of an anti-lesson there. But we are planning to have downstream visible features from this. Like the thing that I'm really excited about is selectorless, which is very much still on the drawing board, but this project is going to basically allow us to do that. As far as like development takeaways from this, I think Miles already touched on this, but definitely the biggest lesson was much better to debug with unit tests than real failures. Because when you get to real applications, you have like screenshot test failures, and it's almost impossible to isolate. It takes hours for each individual failure to try to figure out what the real root cause is. We came into this with about 500 golden tests, which the format of that was we'd have a short input template and then the output instructions, and we'd just check that the output matched. And we had about 500, and they were, honestly, we could have had more. Like, I wish we had had more, because there were certain areas where we discovered bugs later that were extremely painful. But yeah, having enough like very atomic unit tests turned out to be critical for this.
Well, I think that it's great to have this important work going on behind the scenes and to have the goal of like nobody even knows that we were here. I think that's great. But I also think we have to be careful, because I don't want you guys working on this important stuff without getting any appreciation, because it's like you're kind of working back, and it might not be like these cool features that everybody's excited about, but it's actually really paving the way, because to clean up that template definition builder, it's like Ivy, like we waited forever for Ivy, right? And a lot of people don't really pay too much attention to Ivy because we don't need to, but it allowed so many other things that came after it. And I feel like this is kind of the same thing. Like you're talking about like the selector list stuff that we haven't even gotten into that, right? But this is where it's cleaning up this code really just allows for more improvements going forward. So very cool. It's very exciting.
Ivy was enormous. So these instructions that we're seeing, they are Ivy instructions. So Ivy as a project defined this instruction set and then implemented both the runtime and the compiler side. This project was a rewrite of just the template compiler part of Ivy.
I feel like Ivy is, I don't think Ivy gets enough love from like outside of like, because that's the thing, is we don't really need to pay too much attention to that, because when we're working on the surface stuff, we don't always need to know about, what Zone.js is doing or how change detection works. But Ivy really is very cool. So I think this is really cool too. Okay, we have more questions. Pavel? You're muted.
When you were showing the phase of the propagation of the blocks and diagram of each of the view, connecting to there, my question is there, is it when it comes to defer or lazy loading part, is it the instruction of the op is going to be skipped in that terms of rendering, or how it's behaving? Yeah, this one. Because I can imagine like if we are going to have instruction like defer in that block,
Good question.
it's gonna change the behavior or not?
This is part of the challenge. We have all these features.
Because defer is almost same as a, we can say almost same as a lazy loading, we can say, on that part.
So my understanding of it is that we do push I18N op contexts and start and end ops into defer blocks. Under the hood, defer blocks use a template instruction. And you would want them to be internationalized, right? If you have an @defer as part of an I18N block. Does that sound right to you, Miles?
It sounds right. Yeah, I didn't do anything special when I was working on this part to avoid them. So if they're using templates, I would assume that they are indeed pushed in there.
Yeah.
I assume maybe what happens later is probably, you might not need the whole, if the deferred content isn't loaded, like you might not need the whole like content of that message. It probably has some logic later on to skip some of it if the deferred view isn't loaded yet.
Yeah, it's kind of weird, right? Because we didn't add any special logic while generating the message, the I18N message itself for defer.
So
And
I
it seems like,
it's handled by the runtime then.
yeah, it must be.
Yeah. Thank you.
Good question. Arnaud has a question.
Yeah, of course we can see the output of the compiler in the bundle. Is it also possible to see this intermediate state? And specifically, I am interested in the generated TypeScript for templates.
Yes. So if you go to your editor with the Angular language service installed and you right-click on a template, there's an option that says Show Type Check Block. And that will show you the generated TypeScript. So that, that's the other part of the compiler. It's not the template pipeline. That's the template type checker. But yeah, you can absolutely see that. You can see the template pipeline's output if you turn off source maps when you look at the code that's actually rendering the app. The intermediate representation you cannot see. The IR is stored entirely as TypeScript objects, and they never get serialized anywhere.
Okay,
Nice
cool.
and clean. Awesome. Okay, I think we've exhausted the questions. Oh no, we have more. One more for Ari. Ari, we can hear you. Your audio is just weird. That's all. I think it's not your voice that's weird, because I've known you for a long time. So I think there's something wrong with your microphone. But okay, so Ari said, what percentage of the Angular compiler is written with third-party libraries other than TypeScript? I don't think there are any, are there, other than Material? Or even Angular Material is not in the compiler.
Yeah, stuff in the compiler. So the parser, we have this design that I don't like. We have a two-phase parser where we parse HTML first and then we parse IV expressions. But I don't think we depend on any third-party packages per se. Like we may have pulled the code in from somewhere originally. I'm not actually sure that we wrote the HTML parsing part. I don't know if you know the answer to this, Miles.
I do not.
Yeah, I don't know. I can't think of any other third-party packages except TypeScript. It's possible we have like an HTML parsing package, though.
Excellent question. Great.
Yeah, I was impressed that you guys had test coverage, and that you attribute your success with rolling this out seamlessly to that. And I'm wondering if you guys do unit tests sort of like we try to do, and if not, what strategy you use. I mean, are you using tools that we might come across like Jest or Carmen, Jasmine, or do you have something else?
Yeah. So the tests I was describing are golden tests, where we have an input template and then some output instructions, and we check that the output matched exactly. If we're being pedantic, I suppose you could really describe those as integration tests, right? Where we're actually running the compiler and checking the output. We did not really write any unit tests in the classic sense for the template pipeline. I discovered while deleting Template Definition Builder that it actually did have unit tests in the classic sense. In particular, I had a bunch of tests for the I18N context tracking that we were unaware of that might have been helpful to know about. But yeah, really like this suite of 500 plus Golding tests we wrote on the output, you could think of more classically as integration tests. And accordingly, we wrote our own test driver for them, which runs the compiler and has this regular expression-based syntax for checking the output, where we have a Golding that can also have regular expressions in it, so like consume all the consts, for example. The other tests we ran were Google 3's internal tests, which are the tests that random application developers write. Some of our big customers inside of Google are Google Cloud Console is the biggest one. They have hundreds of thousands of tests, millions maybe. Firebase is another one. Gemini as well, a new product. So all these applications have millions of tests between them. And we basically sync the changes into Google and run them. And typically we have to run them overnight because it takes so long. And then we get back very cryptic screenshot failures and have to find the root cause. So I would much rather catch the problems with our own tests.
Yeah. Thank you.
Great questions, everybody. Okay, do you guys have questions other than the template pipeline? Do you have questions about Angular or questions about CDK or the material? I know we work a lot with, and also I know Dylan knows quite a bit about forms as well. Go ahead.
I do.
I have questions on material, but I would give the space for others if they have another questions.
They can raise their hands. Go ahead.
Okay, because I think this question is going to be for Miles.
Are you ready, Miles?
Yep. Didn't realize I was getting myself into a material question session, but all right.
Oh, sorry.
That's fine.
I've seen that there is propagation of material-free version ongoing on the theme. And I've also noticed that when I was going by the design specification, that material-free is basically counting with 4 color scheme. The primary, secondary, tertiary, and varm, I think, or error. I'm not sure. But Angular has only 3 types of color scheme with primary, accent, and warm. So how to work with these changes, or should we wait for the material team to integrate all these 4 schemas?
Yeah. So the primary accent worn is actually, that's from the material 2 spec, and that kind of like, leaked its way into our implementation, and then obviously they changed it for material 3. So specifically, if you're talking about like you could do like matte button and then like color equals primary or color equals accent or something. That actually doesn't work directly in the M3 themes. We have kind of like a back compat mix-in that you can include because everyone's already got their stuff colored using those. So just to make it easier for people, we have a back compat thing, and it will like roughly map those things, right? Like warn and error, they're about the same thing. Primary and primary, obviously, and I forget, maybe accent and like tertiary get mapped, but. It's not, it's not, if you're writing a new app, how I'd recommend doing it. And the M3 theme does actually have all 4 palettes in it. And we changed the color and theme mix-ins so that you can actually request, the secondary color and apply it to your own classes, which I think is a better way of doing it than putting like these color equals things on your components. So that would be the way that I'd recommend it. And then the back compat stuff just kind of exists for people that want to quickly get to M3 and worry about cleaning up that color stuff later.
Okay. Yeah, because I was trying to work with components and changing the colors in to tetrarchy, and then I ran into the issue and like component didn't know what I want from it, So that was the first issue. Second thing, what I want to ask, because I seen that there is a complete change in behavior between M2 and M3 in shadowing versus toning. On the M2, you have elevation level of components by adding shadows level, but on the M3, there is basically toning with white on the white contrast colors. So going to the deep darker colors, we can say. And is this going to be supported by Angular material, or this is not needs to be done by the developers?
For now, it's something that needs to be done by developers.
Mhm.
So we have like the tokens exposed now, like as like CSS variables. So it should be easier to override those to the correct color if you want to do like the toned like elevation levels. We haven't gotten to like, adding any kind of API for that, at least so far. That's something that's on our backlog that is clearly part of the M3 spec, and we may want to look into. But yeah, for now, I think that at least having those tokens available as like CSS variables should help.
Okay.
You being able to do it. Yeah.
Is there any time scheme or time frame when? Oh, I'm not going to say anything. Sorry. Yeah, I was just curious on the M3 because it started to be propagated, but like all these details with toning and using colors and so on could be really helpful for developers to make their application nice. So
we're laughing because I was telling Pavel years ago, I saw somebody asking Brad Green at a conference, when is this feature going to be ready? And he basically said, if we give you, if we promise you that something's going to be ready by a certain day, then we put ourselves up against the wall, and we don't want to do that. So it'll be ready when it's ready. That's why Pavel was asking, when's it going to be ready? And then he stopped himself like, okay, it's ready when it's ready. We're looking forward to this, but we don't want to put pressure on you.
Yeah.
Gotcha.
So on that note, Ari has asked in chat, any news on
Yes,
whether
that was
Form
such a good question.
out-of-the-box integration with Signals. So very much in the spirit of not promising a specific delivery date. I am staffed to work on this in the second half of the year.
Listen, so many people are asking me about this, Dylan. We're very excited about this. Not to,
Yes,
no pressure, no pressure. We're just excited. So we would love to have updates. Okay, so have you started on this yet?
I have not. So currently, we just shipped template pipeline in February, and I'm spending the next couple months working on a Google 3 internal thing. Actually, currently our language service does not run in Google 3, which is a big oversight for us. So we're trying to fix it. After I finish that, I'm planning to work on integrating Signals into Forms, which there's some open questions there. In particular, Forms, if you've ever looked under the hood, uses promise.resolve to propagate validation state back up the component tree. Because in general, if you think about validation in general, Angular has this unidirectional data flow concept, and validation really runs counter to that, right? Because validation
is the whole problem with this thing. It's backwards.
Yeah, validation flows up from the controls, from the leaves to the groups, to the parents. Yeah. And so the way we do that today under the hood is we have this promise.resolve, but with signals, your signals are a really natural solution to this, right? I think Alex likes to say that building a nice form system is a foundational problem for a framework's reactivity system, and that we will know whether, at the time he would say, we'd know whether we designed a signal system we like if we could build a prototype form system with it that behaves well. Something along those lines. But this will introduce some backwards compatibility challenges in particular, because the validation propagates and triggers, on validity changes effects, on validity changes like subscribers to run on the next change detection cycle. And so there's there are definitely some big question marks here about how do we add signals to this without breaking existing applications. Probably we can't use them to drive existing parts of the Forms package. So we'll have to find a way to integrate them that is still a nice developer experience, but doesn't disrupt the way it works today.
Such a good question. Okay, I would definitely because I remember you came back, you came in and talked to us about the strictly typed forms when you were still working. It wasn't even finished yet. It was just a spike. This is what I'm trying to do. And it was really an interesting conversation for us, and it was fun. Then later, a couple months later, to see the RFC come out. So definitely, I think when you start working on that, if you want to stop in and or somewhere along the way when you have time, we would love to have updates about that, because I think There are a lot of people here working on forms in big enterprise companies, and we love signals. And so we're like, should we try to like rewrite it, or should we wait for Dylan, or what's? So we just love the updates.
Yes, our hope is to work on this second half of the year, and I would love to come back and talk about it. There will also be a lot of public engagement. Like, this is a very public-facing feature that a lot of people are really invested in, so we want to get it right. So I don't know yet if we'll do an RFC, but we might do an RFC. And there will definitely be like a lot of engagement on social media and on our Slack and the Discord. So we want to hear from everybody about this.
Yeah, absolutely. Okay, Pavel had another question for Miles about the M3, M2 switches.
Yeah. So yeah, is there a plan to switch M3 as the default for Angular on new versions of Angular, and will there still be support for M2? Yeah, so currently M3, as you know, is in experimental. We're planning on making that stable. Again, no promises, but we're aiming for 18, and that's coming up soon. So hopefully by then, we'll see. But yes, once it is stable, we will make it default in the sense that if you ng add Angular material, that should install like an M3 theme by default. We don't plan to, at least at the moment, like mandate any kind of migration from M2 to M3. If you want to use M2, that'll still just be an option. It won't be deprecated or anything like that. I can't promise that'll always be the case. Like, likely at some point in the future, we will decide that we don't want to be maintaining 2, but that's not a migration that we want to force down people's throats right now. So you're good to keep using M2 if you want, and M3, hopefully version 18 will be stable.
Okay, thanks. Yeah, I can imagine that the migrations could be really hard because of the definition of the design of M2 and M3 is completely different.
Right.
So
that's the thing. It's not the kind of thing we can just like automate for you, right? There are like design decisions that you have to make for your app along the way, and so that's why we don't feel they would be right.
Yeah, I completely see that overhaul of the change of the design. Every enterprise application is used to have the colorful toolbar, and on the left side, nice menu divided by shadows. And now with Switch, this is not going to work pretty well. Yeah,
I think it'll be nice because it's subtle enough. You can tell it's the same, but it's also just a little bit like, if you know what you're looking for, you can easily tell which version people are on. So that's pretty cool. Ari.
I don't know if you hear me well now.
We hear you. It's just a little muffled, but we can hear you. If you're speaking slowly and clearly, it's going to be fine.
Yeah, I tried to change my microphone, so I think it will be better.
It is better.
Okay.
That's better, yeah.
So I wanted to ask Miles, during the last 6 months, I think when M3 was introduced in the materials, there was a problem when you used custom themes, or actually when you override a lot of things in the theme. And this was something that forced me to move away from Angular material, which I was a great fan of the Angular material. So if you have an application that does a lot of overrides of the Angular material components, do you have a best practice or some advice to give what we should do in this situation?
That's what they made the CDK for, isn't it?
Yeah.
If you're fighting with Angular material.
Yeah, it's tough because we definitely understand that not everyone wants the default Angular material components, but like if we try to promise like compatibility no matter what kind of overrides you're doing, we're basically stuck. We can't change anything, right? And so we see this like even within Google, which theoretically should all be using material design, right? Like people have all kinds of overrides, and we try to make the simplest changes and roll them out into Google. And I just want to change this one like border radius here, and suddenly I have hundreds of broken tests. And so if you want to change things outside of what's supported in our themes, you can do it, but you're kind of signing yourself up for having to maintain that as we make changes. And one of the things about the new M3 ones is that there's a lot more stuff that's kind of within the scope of the theme, because we expose a lot of these design token things from the material design team as CSS variables that you can change now. So things like border radiuses actually are something that's part of the theme now. And even if there's no direct way to set them in our SAS API at the moment, I think that's something that's kind of being worked on right now by some of my teammates. But even if there's no API to do that in SAS, you can set those variables like in CSS. They have kind of crazy names like dash dash, I don't know, mat, checkbox, border radius, whatever. And then that should be easier to keep in sync with like our changes, because we do consider those CSS variables to kind of be like part of our API. So that's what I'd recommend. Stick to doing those as much as possible. Avoid just like targeting our selectors and overriding stuff. And I know that there's probably gonna be cases where we have to do it, and unfortunately, I don't have a great answer for that. And the CDK is a good answer. Like if you want something that looks drastically different than Angular material, like you could try to build it based on the CDK components. There's not as many. We haven't had a chance to make as many like CDK components as I would like. I think we're hopefully, now that we're kind of over this M3 hump and it's out, we've been working on that for a long time. I'm hoping that we're going to have more time to work on like more CDK components for people who want things that don't necessarily look material design. So yeah,
I think the material design, because it's creating this stuff on the fly. I've had a lot of people come to me, and I used to be one of the people fighting with Angular material and trying to override it and trying to customize it. And then I really got to know people on the Angular material team, and I worked closely with Austin McDaniel for a while, and he was on the Angular material team. And I learned through my experiences with Austin and through all of the enterprise material stuff that I did, that if you want to fight Angular material, you will lose. Like, don't fight it. Just go to the CDK. It's like raising teenagers, right? I don't want to fight you, but if you want to fight, you're going to lose. Don't try. I mean, it's like Miles said. I mean, sometimes, they tell you that you need to do this. And so obviously you want to be accommodating, but if at all possible, try to avoid overriding things and go to the CDK if you can, and or override it at your own risk, because it's just not generally created for that. But it is getting more flexible. And yeah, and if you find yourself fighting with Angular material, give up, surrender, and go use the CDK. That's always been my advice. But yeah, it would really be it would really be nice to have more, like everything from material in the CDK, because we don't have all of them, but it's very handy, because basically the way that I remember the CDK being what's that word? Introduced. I forgot the word introduced. The way that I remember the CDK being introduced by the material team is basically, this is material without the CSS for that reason, so that you don't have to fight with the CSS stuff.
Yeah, it's got like, the interaction patterns and like the accessibility and all that stuff, but the styles, there are no styles, so you style it however you want. You don't have to override, because we're not going to fight you on it. It's all you when it comes to the style.
And Ari, we were talking about the snack bar a couple weeks ago. Pavel, you and Pavel should chat about that, because we were talking about that with Edward in the architect space last week, I think. Cool. This is fun. Okay, we can't keep these guys all day, because I'm sure they have work to do. Does anybody else have more questions? Going once, going twice. Okay, I have a couple of last minute. If anybody else has more questions, put your hands up. But I have. Okay, so Dylan.
Yeah, while we're still here, actually, I did think of one more answer to that question earlier. I forget who asked it about what are going to be the user-facing ramifications of template pipeline. There's been a lot of public talk recently about. Yeah, there's been a lot of public talk recently about convergence. This is one more answer I thought of while sitting here, which is having this IR might eventually help us converge more features with Wiz. We already share a signals library with them. Now we're talking about getting JS action into Angular, which will allow us to replay events that happen before hydration occurs. And in the long run, we've been talking about what else could we converge? Can we converge authoring format, or at least partially converge authoring format? And that's something having an IR will be enormously helpful for, because we can kind of target this IR from multiple authoring formats, or we can have the same authoring format compile through the IR to multiple compilation results. So that's a very long-term vision topic, right? But that's potentially one application of this project, is furthering the convergence effort.
I love these discussions because it's so helpful to understand like how things work behind the scenes, and how these things that we might not pay attention to open doors for future innovations and collaborating with other teams, and it's just, I love to see it. Very cool. Okay, and that's really a perfect segue to my next question, because I wanted to ask you guys, because we were talking about the compiler with Alex Rickabaugh when he was here. Him and Pavel were talking about signals and state management. So you and Miles might have separate answers for this, which is totally fine if you do. Do you guys have recommendations for other things going on in the Angular team or the CDK, or anything that we should know about, anything that we should be paying attention? I think we have Matthew coming up. He's cool. The mysterious Jean Mesh.
Yes.
I think we're going to try and get him coming up soon. Is there anything else that we should know about? Anything else that you think that we would like to hear more about?
Here's some random stuff that has been on my mind recently from looking at design docs and talking to people. Matthew is trying really hard to land a new unified control state change system.
Yes, that's what he's talking about. Yes.
I've been trying to get it in all week, and it has broken tests in Google 3, which translates, of course, to there will probably be breakages externally, so we want to fix it. But it's like people screenshot tests. I'm still trying to get at the bottom of it. But we are hoping to get it into V18. So that I'm super excited about that, because people have
maybe
been
you
asking,
could come back because I think Matthew's going to be here sometime next month, and maybe you could come back when he's here and talk about that with him.
Yeah, happy to come. I don't want to hijack his talk or anything, but
no, it's, you guys are more than welcome. It's a cozy group. It's fine.
Yeah. So you'll be able to like subscribe to Touched State once he finishes that. Another thing is Jessica and Andrew Kushner have been working on partial hydration,
Yes.
which people have been asking for years. This is also really tied up with the ongoing JS action work. JS action is the Buck Wiz or like Wiz concept that lets you replay events after the app hydrates. And I think that is, I'm not sure what the exact state of that is currently, but I think this all tied together as part of the big what do we do next for hydration project. So that's super exciting. Signals-based components are on the horizon as well, like fully reactive control flow. They were in the original RFC, and we've been making incremental progress in that direction with every minor version. We've released a lot of stuff like model input, output, and we're getting closer and closer. I think there's a signals-based query now. Let me think. Do you have anything you're excited about, Miles?
Yeah, Amy has been working on the ability to like generate your own custom color palettes for M3. So right now we have like some predefined ones, but hopefully for version 18, there's going to be just like, give like a seed color and it'll generate a color palette for you, a whole theme for you, which is something
Pavel's been working on that too. So
over.
That will be, so Pavel, you might not need to build that because Amy's going to build that for you.
We'll see.
Well, I was working on Material 2 version to changing, because I was basically able to put CSS variables through the palette and change it on the runtime level. But
yeah. So this would be from TL3, and I don't know about runtime. I mean, the thing that Amy's working on is compile time. Although I think you could do a similar thing with variables and kind of do a runtime one.
Yep.
So that's on the horizon, and then the components team. So then we've just kind of like finished up this huge project now, and so I think we're going to be open to maybe work on some new stuff that's been on our back burner for a while. I can't say like exactly what that's going to be yet, because we have like a team summit coming up in next week, actually, I think, where we're going to like discuss more about it and like what our priorities should be. But yeah, it's good news that we're going to have some more bandwidth to work on things other than Material 3 now that Material 3 is kind of out there.
Yeah.
Having more CDK components will be really cool.
That's what I'm advocating for. We've got to have the discussions. That's definitely what I'm advocating for.
Keep us posted. We're very excited about that. We will be anxiously awaiting updates. And yeah, it's really cool to have you, Miles. You're more than welcome. Both of you are always more than welcome to pop in anytime or ping me on Slack, and we'll put you on the calendar, because we really love to hear from you what you're working on and what's going on, and even the challenges that, like, I want to do this and it's a pain in the butt and I'm working on it, and it's really fun. I think it's interesting for us to know what's going on behind the scenes, because we don't ever really see that kind of stuff. So very cool. This template pipeline is I know it's like, I love, like you said, you want to do this so nobody knows that you changed anything, but also you're paving the way for a lot of future improvements. So
Yes, yeah, this is very much one of those under the covers projects. We haven't been giving a lot of talks about it because I think it wouldn't make a good conference talk topic. It's so much Angular internals. We gave that talk to a group of internal developers recently, and then to you guys. But yeah, it's very much something that is concealed and will enable us to do other things in the future.
Well, we're next level nerds, and remember, we love Angular, so we're always curious to see what you guys are doing. We think it's cool. Okay, I'm going to wrap it up. You guys know the tradition here at TechStack Nation. Please come off mute and help me thank our guests.
Thank you very much.
Thanks, guys.
Thank
Thank
you.
you guys. Appreciate it.
Thanks for having us.
Yeah, thank you.
Did it.
Absolutely.
Yeah.